Okay, so I'm going to do a proof using the pumping lemma to prove that a language is not regular. In particular, I want to prove that a to the n, b to the n, such that n is an element of n, is not regular. And note, by the way, that I am using my outline of pumping lemma for regular languages, which you can find at www.edu/k/classes/found/handouts. And in there it's called pumpingoutline.pdf right now. Pumpingoutline.pdf. Okay? Alright, so I want to prove this. So here's my proof. Let's let L equal the language a to the n, b to the n, such that n is an element of the natural numbers. Let's assume that L is regular, right? And let M be the number from the pumping lemma. Okay. And now comes the tricky part. We got to pick a good string S. Well, let S equal. The requirements on S are that S has to be at least M characters long, and I'm going to pick the string A to the M, B to the M, right? That's definitely M characters long, right? That's actually 2M characters long. Since S is an element of L, and the length of S is greater than or equal to M, the pumping lemma must apply. Specifically, S can be split into X, Y, and Z, where Y does not equal lambda, and the length of the XY part is less than or equal to M. Okay. So now we need to say something about Y. Well, since XY, the length of XY has to be less than or equal to M, that means that the XY part has to occur in the first M characters. And so that means in particular that Y has to occur in the first M characters. So Y must equal A to the something. Let's call it A to the K. Y has to be all A's, right? Y equals A to the K. Where, let's see, K, well, K has to be greater than 0 because we know that Y does not equal lambda. And K has to be less than or equal to M because, alright, XY, the length of XY has to be less than or equal to M, and I suppose X could be empty, and that would make K M. Meanwhile, let's think about X. X is also going to have to be all A's. Let's call that A to the Q. Where, let's see, Q could actually equal 0, but Q has to be strictly less than M because Y has to have at least one A in it, so we lose one of those A's. So Z is everything else. So what's Z? Z is any A's that are left over, so that's going to be A to the M minus K minus Q, and then B to the M. Okay. Well, now that we know that, let's see. The pumping lemma says that XYYZ is also in my language. Well, what's XYYZ? Let's see, XYYZ equals, let's move to the next line. No, we'll stay here. XYYZ is a to the q followed by a to the k twice, right? There's my two y's. Followed by z, which is a to the m minus k minus q b to the m. All right, well, let's see. Let's mess with that. That's the same as, these are just all a's in a row, right? So that's a to the q plus k plus m minus k minus q times b to the m. Well, followed by b to the m, right? And if we look at this, this q and this q cancel out, and this k cancel out. So we end up that equals a to the k plus m b to the m. But hang on, a to the k plus m b to the m, that's not an element of L. But it has to be an element of L because it's x, y, y, z, and the pumping lemma says it has to be. But it's not, but it has to be, but it's not. So we have a contradiction. Given our contradiction, we know, thus, our assumption that L is regular must not be true. Thus, L must not be regular. We're done. QED.